Good afternoon. Welcome to the Hong Kong Academy of Engineering Science Distinguished Lecture. My name is Lim Cheung. I'm the moderator for this talk. Let me start by saying a few words about the Tech Talk. The Tech Talk is a series of forums and dialogues given by engineering researchers of diverse academia background to share their insights on innovation-related topics. Today we are very fortunate to have Dr. Justin CHUANG of ASTRI giving the talk. Dr. CHUANG's title is Towards 6G, the Impacts of Wireless Communications Technology Research to Society. About the speaker, I see it's here, so I don't need to read from the piece of paper. Dr. Justin CHUANG has a very diverse background in academics, industry, and entrepreneurial activities. So he was a professor of Hong Kong UST about 10 to 15 years ago. He worked in Bellcore and AT&T Labs. And then I think he came to Hong Kong UST, and then he returned to AT&T Labs. And then look and behold, he founded a company. I think what's the name of your company? Mobile Link, right. It is very successful. And then he sold the company to Broadcom. So it's quite rare you have a professor become successful in industry and academics and also entrepreneurial. So today, after joining ASTRI, Dr. CHUANG and his team leveraged the collaborative efforts among government, industry, university, and research organizations to drive the advancement of commercialization of enabling technologies for 4G, 5G, and beyond. So actually, I recall Justin actually started with 2G, 3G, 4G, 5G, always at the forefront. And then he and his team put Hong Kong on the map. Because when you go to the MGW, the Barcelona, so you always see the ASTRI team breaking a record there, year after year. So without further ado, let's listen to Dr. CHUANG's talk on 6G. Thank you.
Thank you, Lim. Actually, Lim recruited me to ASTRI 13 years ago. And I joined HKAE more than 30 years ago. So you can figure out at that time, it was not 5G or 6G. It's 2G and 3G. Every 10 years, there's a generation. So it's easy to talk about. So I would like to give a point on what 5G had achieved. Then using ASTRI cases as example to see how we solve the pain point of the society and how we can customize application. And then from here to 6G, there are some opportunity and challenges. And I want to say a few words about that and before concluding my talk. So what 5G has achieved? Let's review generation. Here, I'd like to make a comment. Every even number G is a successful one. So I'm not trying to say 5G will be a lost, but 5G would certainly pave the way to a very successful 6G. So we use the title towards 6G for a reason. But if you look at the early 80s, that's when I started my career. They have an analog voice based on frequency modulation, FM, radio technology type. they try to put people on the move while being able to talk. And that was interesting, but not very successful. And the real breakthrough come in the 90s when Bell Lab decided not to do any wireless research. At that time, US focus was optical communication. So most of the wireless research is in Scandinavian countries. So I flew to Scandinavian country quite often. And turned out it was a very successful application of digital communications for making the call. And then after that, people say, since everything is digitized, we should start doing internet. Actually, internet was not as popular. It was just data, right? But the speed is too low. So 4G came in 2010s. That's around the time I came to Hong Kong. And as you can see, 4G is quite successful, can do a lot of things. And I'm still using 4G. And I'll say a few words about why you have to move to different generation. 5G promised a lot and launched in the 2020s. And now we are actually already talking about 6G. So what's the point of talking about all the generation, even before you take all the advantage of different generation? So a very important point is 5G has a vision not only for the speed of communication, right? In the previous generation, people always say how fast you can do. So we will continue to improve the bit rate. But now there is a focus of another triangle on the basis. One side is latency. So you not only want the higher bit rate, but you want the response to be quick. And that's called latency. And there are a lot of examples needing that kind of metrics, and I'll give some example. The other thing is massive machine type communication, because everything in the future, it doesn't have to rely on human communication. So you have to be able to connect a lot of so-called IoT device, Internet of Things. So when 5G was introduced in standard body, they have different metrics driven by a lot of communication theorists as well as practitioners. And in fact, the standard is very good and achieved quite a lot of this. And at the same time, there are new technologies introduced that was not really as popular in 4G. For example, you have much more spectral bandwidth. In the early days, the communication bandwidth is about 1 gigahertz range. And in 2G, in the 3G, 2G, it began to use 2 gigahertz range. But now people are talking about low band is under 6G. And people are talking about 5.5G and 6G. They introduce some band a little bit higher. And high band is something I'd like to say a few words, because people are already talking about millimeter wave. Millimeter wave is roughly on the order of 30 gigahertz range. And that offers a lot of opportunity to increase the bit rate. But the propagation property will also make it shorter range. And how do we overcome that? And that's where something like massive MIMO. MIMO is multi-input, multi-output. That means you have multiple antenna in the handset as well as multiple antenna in the receiver side in the base station. And there are other technologies being introduced, standalone, non-standalone dual connectivity, and by taking advantage of different band combination, making it very complicated. But one of the important reasons we can do that is because of integrated circuits. So it comes back to the importance of semiconductor industry. And there are also spectral sharing, and I highlighted millimeter wave is the promised land to give you higher bandwidth and higher bit rate. And on the networking side, you also have a lot of innovation. Network slicing is a concept where you can put different type of services in different sizes. So one size may be for typical voice. There are slices that require very quick response time, low latency. So you can provision that in the network side. And that's why it's not just radio access network. It also includes the network core technology. We have a colleague, Yolanda, is responsible for that type of technology. And once you have all that, you have a lot of opportunity to connect to cloud and edge to take advantage of big data. And once you have a lot of data, you can use artificial intelligence to do a lot of things that in the past you can not imagine. So look at the 5G connectivity. Look at the percentage of penetration versus timeline. And today is toward the end of 2024. Look at that. 4G is still much higher, but it's in the decline. 5G is going up. But actually, it's very important to understand that even though 5G is introduced in the early days, and for quite a few years, we are already talking about 5.5G. The penetration rate for 4G is still higher, and only until 2028, 5G will exceed. But at this point in time, researchers and standard body start thinking about 6G. So the point is that technology is there, but the market development is still in relatively early stage. That means there are a lot of potential that has not been unleashed yet. So look at the Hong Kong coverage. Hong Kong traditionally has very good coverage. And if you look at this chart, you know that over 90% in Hong Kong is already covered by 5G. And I want to highlight a new spectrum that is millimeter range, 20-some gigahertz, and with different operator has different bandwidth. But typically, you may or may not be able to take advantage of that because relatively speaking, people are still using the typical frequency range. And I want to talk about that because it offers a lot of potential for future services. Yeah. Okay. Whoops. I should go back. Yeah.
See, there's a line coverage, like a line on the ocean, right?
Yeah.
What does that mean? Is it due to the measurements, like the 5G connections, or is what?
Where?
The purple lines.
The purple line, yes.
Yeah, over the ocean, right?
Yeah.
There's some of the line actually are on the ocean. What is the operator purposely have coverage on those, there's a route where the
Yeah, it's interesting. I don't know whether that's a bridge or not. Yeah.
No, there's no bridge on the southern part of the Hong Kong island. I'm very sure.
Oh,
I
you,
quite a lot there. I sell quite a lot to the island there, but there's no bridge at all. So I wonder, and there's not many boats as well. So I wonder what does that mean? Maybe catch for the ferry. No, but there's not much ferry there.
yeah, that's a good point. We should try to figure out. I don't know. I know.
This is the smart home, right? So we can go up to the because if you go back, they are talking about 4G as well,
I know that some company is trying to use millimeter wave for private network, and I don't know whether that's part of it. I'll give you an example later. We just have a project approved to do a public sector trial scheme to work with housing authority. And we want to take advantage of 5G coverage to control the crane. And the spectrum is actually owned by Smartphone. But my understanding is a lot of company has spectrum, but not really in typical consumer service yet. The biggest private network in millimeter wave is Hong Kong Airport. And ASTRI was working with Airport Authority and Huawei and China Mobile Hong Kong to ensure that private network is done properly. So that is purely for airport operation. So I don't know whether this is one of those examples or just simple mistake.
But they probably using the millimeter wave to connect those islands.
Yeah, frankly, a lot of this, as long as they have footprint, they just put it there. And I'm not sure you achieve a lot of service at this point in time. The most service is still from streaming and regular data transmission. Yeah. But I say a few words about the promise of that to lead to why 5G people want to push the spectrum higher and higher. So the lesson learned is 4G smartphone service are pretty good. Why do you need 5G? Right? This is this iPhone is 4G only. I have a 5G phone from AT&T last time, but they have a US operator lock the SIM, so I cannot use it here. But anyway, then 5G, if you think about the signal processing and all this antenna, you can imagine heuristically, you will create a lot of energy, need a lot of energy, and it's complicated. The third point I want to make is typically if you buy infrastructure from Huawei or Ericsson, Hong Kong has two infrastructure vendors. It's a black box. If you want to have particular application, you have to talk to them, and they don't open interface for you. And so it's very difficult to customize the service you want. And I want to drive one point is that you need some use case development in industry engagement to drive the innovation. So 2007, Steve Jobs introduced iPhone. That's what I call iPhone moment. With that platform, people can do a lot of things, but mainly streaming, use it as a mobile device to do regular internet and other things. But 5G promises a lot more. They want a device that can react very quickly. We are still looking for that device. And the second thing is you need standard effort. And the organization called 3GPP, third generation partnership project, has done a wonderful job. So even though we are talking about 6G, the main body is still called 3GPP. And historically, it's because during the 3G, people talk about US version of CDMA, US version of TDMA, and outside US version of WCDMA, and also Chinese version of TD-SCDMA. So there's an important effort to consolidate that. And the result is that there's an organization called 3GPP. And at least in that time, we have multiple standards coexist, but they can talk to each other in certain way. So that make it pave the success of 4G, and now they are moving to 5G and 6G. And one let's talk about point is open interface, because some of the vendors are good at making radio, some are good at making signal processing. And if you open more interface, it has chance for innovation. And so there is something called Open Radio Access Network. But at this point, people are still not convinced it's the best, because as we know, in any system, it's always better to optimize your system by together. So people in the industry, it is still being debated whether open interface is the way to go. But personally, I think it's going to happen regardless, because we have seen the wire industry went through this breaking the interface, and turned out in the beginning we also faced a lot of resistance. But in the end, it's very good that different players can play different role. And that is also an opportunity for customization, because if you open certain interface and let people, say for example, do their innovation in application area, then you can base on the same hardware to do many things. And that's the point I want to drive, because you need useful application that can leverage what technology and standard give you. So I want to quickly go to 5G project to give you some example how they solve the problem. First of all, in order to do that, you have to have an ecosystem. And in Hong Kong, we are fortunate enough to have excellent university doing excellent research, and we have government willing to try different technology. And we have supportive funding agency, including ITC, Transport Department, and OFCA, willing to look at the spectrum. So in Hong Kong, it's really relatively quick for us to put together a partnership and working with the upper partner who may be owning spectrum or owns their platform, like MTR. They need to solve some problem, they work with us. Bus company, they want to do autonomous bus, so they work with us. So these are very important. And then, of course, you need a network vendor as well as ODM and chipset vendor there, so we can program a special platform for you to leverage the advantage of 5G or even later 6G. And we are fortunate to have that in Hong Kong and GBA and other parts of the world. So over the 10-year plus time, we developed 4G, now 5G, and starting looking at 6G, working with university. to have an end-to-end solution. And that's very important because if you look at the metrics, I want speed, I want latency, I want massive IoT connection. And in order to do that, you have to have boxes which can transmit and receive spectrum. But you also have to have processor, right? These looks like a server, computer server. In fact, the baseband processing is down there. And then you have another box doing core, 5G core, and mobile edge computing. Now it's called multi-access edge computing. And if you connect that together, you can connect to cloud to do all kinds of things and do orchestration here to configure different type of application. And being able to customize for what you needed is an asset to Hong Kong and everywhere, because you no longer deal with black box. Remember I say if you want to do something, you have to talk to big vendor. But big vendor look at your demand. They will say it's not big enough, so why do I bother to customize for you? But if you have a boxes so small, you can easily program. That give you a lot of potential. And that's why I also emphasize the importance of breaking interface. And the interface in 5G is already make it much easier to customize. And with that as a foundation, now we are looking at different type of 5G R&D. And I don't want to repeat what the operator are already doing. I just want to give you some example beyond what you can talk with a regular telephone from China Mobile. Give you first example. We just proposed a project to extend range and robustness. Say in the area near the ocean, a few years ago, there was a fire on the boat when electric company was celebrating National Day, and that's because there's no cellular coverage. And by doing this, just modifying our boxes a little bit, plus some external antenna processing, we can track the boat when they are moving. So that's the coverage. And the second direction is 5G everywhere. And I'm talking about non-terrestrial network. So we are talking about 3 dimensions now. So in 3GPP, people start to talk about satellite coverage. And satellite typically has geostationary satellite. It doesn't move, but delay is terrible. So the trend is going to low Earth orbit, LEO satellite. And in the policy address last week, our chief executive mentioned low altitude economy. That is really strong. And if you think about 5G everywhere, we want to put 5G on a drone that is lower than satellite. So this is also an area that we are start looking at in 5G, but in 6G, it will be designed as part of standard. And number 3, you need a very quick infrastructure set up in an emergency situation or in a remote area. And we have this access and backhaul I'll elaborate a little bit more. And number 4 is with all this edge plus cloud and AI, you can do a lot of intelligence. And as I mentioned, if 5G is just a device for typical streaming and talking to your friend, we really don't need 5G. So it's very important to look at possibility of using it in the so-called Industry 4.0 or even beyond. And we have example to support factory operation with time-sensitive network and launch robotic operation from the cloud. And finally, this, last but not least, is the autonomous driving. But in this, we want them to be connected together. So we call it CAV, and I'll say a few more. So the use case, as I mentioned, is the coverage in the coastal line outside Hong Kong Island where they are both moving around. And in the remote area, you need to support mission control. So on the right, I'm trying to show you how we can modify the boxes that you have seen in the previous few pages by adding physical layer improvement, by putting more software in there, and by putting more antenna to do so-called MIMO operation. So this example, we want to have 32 antenna in base station, 8 antenna in the radio devices. And by working with a Hong Kong company, we have some algorithm so that we can steer the beam between the terminal in the ship with the coastal base station near the coastline. And this is one example that if you don't have a black box, and if you own the technology, you can modify to do many things. And that terminal can be relatively cheap because it can model, take existing terminal and do a little bit of enhancement. And we already have a customer in Hong Kong doing that type of work. We just put more sophisticated tracking algorithm so they can do this automatically. And the other is satellite coverage. Again, the same thing. As you know, Elon Musk has a company called Starlink, and they have a launch space company called SpaceX. And Starlink is their service in the low Earth orbit. But they don't, you have to buy their service end to end. And the goal for 3GPP in 5G, just the beginning, and 6G is to aim at design so that you can support different satellite scenario natively. And the reason is that if you have a mass market standard-based handset, the cost of doing satellite communication is much cheaper. If people recall in the 90s, there's a company called Iridium launching many satellites, but the terminal is very expensive. And even Elon Musk's Starlink, they have been very successful, but you still need their particular antenna. And once you receive the signal, you can distribute by Wi-Fi or other means. And so you can see that satellite communication is very powerful. And if you can design it into the system with a major 5G phone, it's very good. So for example, iPhone maybe start from 14 or 13. They already have the emergency call capability, but not full-fledged 5G function. So this will be something that in 6G standard will be designed natively. And this is an example of working with information theorists. Chinese University has a very successful program called network coding. Raymond Young and Song Lu, etc. And they have started a company called NHub, and we work with them with our existing base station from customer, and outside using their network coding as an outer code. And by doing that, you can have very reliable different hub. For example, in area like 郊野公园, country park, where you don't have very good coverage, or you need a very quick infrastructure, you can have this happen. When we talk to some people in mainland China, they are very excited because they have a situation in highway. You don't want to have a lot of coverage, but you need a longer hopping distance. And also the mine field, underground mine is an example. This is an example of time-sensitive network that Yolanda's group is doing. What we did is to put the synchronization between outside network and 5G core network. You have a translator. You have a device side, you have a network side. And if you can do some processing, as you can see, the machine can, robot can move in sync and create a very low latency. More importantly, it has very low jitter. And ultimately, our goal is to facilitate the factory with completely no wire, even between the robotic arm. It is done by wire signal. But you can see that's a little bit early in time. But 5G standards start with a latency low enough for you to start thinking about that possibility. And that work will continue in 6G with improved latency response. And if you can do that, when you have to change the production line to do manufacture different things, you don't have to remove this cable to do a lot of reconfiguration. And more importantly, in the factory, you can combine operation and IT, CT, and OT operation technology together. And that is a very powerful proposal. And we are working hard on that kind of possibility. I think a lot of companies is trying to design chip to achieve that. And the beauty of that is industrial 4.0 standard do not need to count on standard industry-based protocol. It can just run it on Ethernet, but with time-sensitive measure to improve the performance. The other thing is we also found out localization service plus sensing with position fusion plus the 5G communication can do a lot of robotic deployment in area where it may be dangerous or dirty to do. On the right-hand side, is a case where in the factory, we want to use this type of technology to move parts from one place to the other and also have some coordination. And that gives you very high efficiency of the factory operation. And lastly, the so-called vehicle to everything or connected autonomous vehicle system. We have launched a trial from Science Park to Shatian with purely connected car system. Basically, you put the roadside unit and sensor on the roadside, and the car inside has an onboard unit, so they can communicate between cars, communicate with other network nodes. And we are trying to put one step further to combine with autonomous vehicle. As you know, there are a lot of autonomous vehicle trials in different parts of the world, but in a Hong Kong environment, you have car with different speed, you have pedestrian, you have even autonomous vehicle with different degree of sensing capability. So it's very difficult for them to just run it together, because the end result is that there will be a lot of accident. So we mandate the communication network that can combine them together and fuse the sensing result. And we are in the process of doing some trial. And early next year, we'll have a autonomous bus connecting between University Station and Science Park. And in between, it had to go through 3 traffic circles, and that's very challenging. If you have an autonomous car, a lot of time, it can never have a chance to enter the circle, because if their algorithm is not aggressive enough, they will just stay waiting for the car inside. As you know, Hong Kong drivers are quite aggressive. So if they don't let you get in, you can never get in. And that's what I see. A few years ago, when I went to Google to see their autonomous vehicle trial, their car is too polite, and sometimes they get hit. They don't hit people, but the other car hit them. So in order to solve that kind of problem, you need network connectivity. And with that, you need edge in the roadside, and you also have to have some AI capability to train the algorithm. So some application example, as I mentioned, 2.6 kilometer to be launched with city bus, with transport department in, between subway station and Science Park. And we have airport collaboration to launch 5G infrastructure with millimeter wave. And private network for public safety. Recently, we just finished a trial with Hong Kong police, and they are very happy with us, because Hong Kong has a spectrum Huawei doesn't support. So we were able to customize the spectrum so they can work with us. They are planning to deploy this in the airport later. And I want to give an example in the lower, in here, lower right-hand side, smart contraction side. to do real-time safety tracking with wireless backhaul and millimeter wave. So here is the Inner Hong Kong office. Inner Hong Kong, I think, is by Professor Li Zexiang in Science Park. Their mission is to do construction technology, including crane and control center. But they put wire together for connection. Now we want to remove the wire, but replace by 5G end-to-end with radio-based band unit core network. And on the crane side, you will have a terminal right here. So we have a wire. In a real operation, you can just put this terminal here. And we just have some early result. The project was approved today, but you can see that remote control side can do some control with the joystick, and you can move the crane. And 5G terminal connected to the tower train, and in between is all wireless. And this is what the control center can do. So you can see that it can make the construction site much safer. And Smart Home has a spectrum. They are working with Xin Hongji. They want to do some trial with this. And the crane will be made by Inner Hong Kong's project. So hopefully, this will be an example that you can have 5G with real use case. And obviously, we have a lot of work to do than just do the demo. But if you can do that, the construction will be much more efficient. I think one of the focus of that Inner Hong Kong is to do also have a prefab technology, so you can pre-assemble certain element and then use crane with control to do that. And that is part of the promise from CE to construct more housing. And we are happy that we can contribute. So from here to 6G, one important point is artificial intelligence will be much, much more mature, and we will be able to make it to enrich human life. And in 6G, it also has the same vision, but with some improvement in the traditional triangle in terms of speed, response time, and connectivity. But there are new elements. That is ubiquitous connectivity, like the 3-dimension I mentioned, satellite, drone. The second thing is they want to integrate AI and communication together. And the third element is integrate sensing and communication together. What happened is radio wave by itself is able to do sensing, especially high frequency, like millimeter wave and above, because we are already using millimeter wave radio. And if you can integrate using the same spectrum, doing sensing and also communication, it will be very efficient. And typical example is right now, a lot of people are trying to use drone to deliver things. And imagine if everybody want to do that. It's very dangerous because drone is everywhere. So how do you design a roof for a certain drone so they don't collide with each other? That requires sensing capability as well as communication capability, so you can do so-called geo fencing, so people don't invade other drone. One drone don't invade other drone space. So this is an active new topics that will be designed natively in 6G, but we are going to do something in 5G. So maybe early next year, ASTRI will propose a project to do that, targeted to serve low altitude economy. And there are a lot of challenges. And of course, as I mentioned, right now, 4G penetration rate is still higher than 5G. And why in the world are we already starting to talk about 6G, right? So it's same question people will ask. But university always have to move ahead of everybody else. So people start thinking, what would be something that 5G have not achieved? One area is immersive experience, AR, VR, right? But if you think about Vision Pro by Apple, they are already talking about that possibility. But the device is still not affordable and is still awkward. I think Meta have make the device much more effective, attractive, but still not completely there yet. And 6G would like to tackle that kind of problem from the beginning. And sensing and AI are two elements people want to exploit in a communication standard so that they can design from the beginning with sensing capability and make AI natural in the system. What I'm saying is they will design interface so that it can allow data to be trained and to be taken down to make decisions. So that will be part of the standard. So, and global coverage, satellite and so on. So there are some cautionary tale from operator, but because of time limit, I will not say too much. The key point is they want it to be thinking about how much you have to invest and what kind of implication to environment the technology will be to the society. And one example, one question people always ask is, does it have to be evolved or complete a revolution? A quick answer is communication technology can never be totally revolution because you want device that can transition smoothly. And there are a lot of proposals and gradually some will be eliminated, some will be enhanced. But there are a few areas that people have to have in mind whether certain new air interface can be implemented with reasonable cost. And there are very interesting ideas for the people to change the environment by doing reflection, reconfigurable intelligence services. And that is an exciting area, but I also caution in a real deployment, how do you deploy in a real environment? And people talking about whether we can push higher frequency. The question is, propagation is going to be so short, and devices are going to be so expensive. Can we achieve this in 6G? There are a lot of questions. So I always joke with my colleagues that wireless communication is a lifetime employment. If you cannot do it in 6G, you will do it in 7G and 8G. And by then I will retire and enjoy all this. So as I already mentioned the area we are looking at, but before I close, I also like to say a few words that even in this area, we can do something similar to ChatGPT. We are working on some early study of taking traffic data and see whether you can train it so that in a real environment you can see potential danger and help you improve the safety in the highway. And obviously this will need a lot of data, but early thinking is we can take different type of data, like map, like traffic, and like the trajectory, and combine them together with multimodal design, and then do the training with large model, and then you can spot potential danger. And this is in the early stage. Right now, we think we have some good idea how to do it, but we also found out the big challenge will be to find enough data to do the trend. And of course, we also need a lot of power to do the training. And this will remain to be challenged for many projects in the AI-related project. But I'd like to conclude by saying there are still a lot of potential. 5G still yet to be fully explored. And we can do something beyond just making a call and enjoy the services on a smartphone. And 6G is going to be there, whether you like it or not, roughly in 2030. And some of the things is going to be an evolution. And we will have revolutionized. But to me, more important is whether you can have revolution in business model and application platform so that people really like it, like what Steve Jobs introduced in 2007, iPhone. There will be a device somebody like, and everybody use it in the future. So there are a lot of technology that need collaboration in the industry and academia, including AI, ASIC, cloud, edge. And as a research institute funded by government, we like to have an open platform so that we can continue to address real need and ready for 6G. Thank you.